To start off our next unit, Unit 4 on electrons, we're going to talk about the energy levels and orbitals that I've referenced before. So up to this point, remember, Rutherford had found the nucleus using the alpha waves hitting the gold foil sheet, and J.J. Thomson discovered electrons with his cathode ray tube. But we didn't know exactly how this was all fitting together. There were still big questions like, where were these electrons? Why do different elements have different properties? How did these atoms combine with other atoms to make new chemicals? And learning more about electrons and the energy levels and the orbitals really helped us come to be able to answer these questions. So Rutherford's student, Niels Bohr, was the one that ended up finding that electrons move in specific paths around the nucleus. They're called orbits or energy levels. Now, these orbits have very specific energies. So the electrons in the first orbit have a different energy than the electrons in the second orbit. That's why we call them different energy levels. Now, one thing cannot have two different levels of energy at the same time. So electrons have to exist only at one level at a time. They can't exist in between these levels. They can jump up and fall back down if they get more energy or if they lose energy. However, they can't exist in the spaces in between. Now, as we kept getting more information and new discoveries were made, particularly those of Schrödinger, you may have heard of him with his famous cat, we developed the quantum model. And this model helped us not only find the possible energies of the electrons and their energy levels, but where to find those electrons. And that's what the orbital is. So it's the probable location or the possible location of an electron as it's orbiting the nucleus. They show where the electrons might be found depending on their energy level. So there's 4 principal energy levels that we are going to be discussing in this class. And each energy level holds a different number of electrons. When these energy levels hold the maximum number of electrons possible, when they're completely full, we say, they don't want to combine with other elements. It's when these energy levels are slightly empty or completely empty that the atom wants to combine with other elements. It's the electron itself, as I've mentioned, that allows chemicals to combine and react. So if you can hold 2 electrons in one energy level and you only have one in there, it would be in your best interest to fill it up so that you can become stable and not react anymore. That's the basis behind these chemical reactions that we're going to be talking about in the next couple units. So these 4 energy levels that we're going to be discussing, level 1, we sometimes say n equals 1, holds 2 electrons. The second energy level can hold 8. Level 3 can hold 18. And level 4 can hold 32. Now, how exactly is that broken down? Where are these electrons inside this energy level, and how do we know that they can hold this many electrons? Well, that goes back to the quantum model with our orbitals. There's orbitals called S, P, D, and F that we're going to be talking about. And each one can hold its own number of electrons. The s orbital, this one here in green, can hold 2 electrons. So what it's saying is the s orbital looks like a sphere. And within that sphere, we're not exactly sure the 100% location of, oh yeah, this electron is right here, right now. We just know that 2 electrons can exist in that orbital somewhere in that sphere's space. The p orbital is the next one, and it is all of these purple ones here. And they have very funky shapes. They kind of look like figure eights here. And technically they're all combined, but we pull them out so you can see them a little bit easier. And each of these can hold an electron. Really, the electrons are moving in between these areas here, so each one of these is holding 2. So if we take 2 plus 2 plus 2, the p orbital can hold 6 electrons. If you do the same thing with our d orbitals here on the bottom in blue, they can hold 10 electrons. And the f orbitals that I don't have a picture for here because the shapes start getting very wonky can hold 14. There are some orbitals above this, but like I said, we're not going to focus on those in this class. Now, how do these energy levels and orbitals relate? Well, energy level 1, if you look at the table here, can only hold one type of orbital, orbital s. So we call it 1s based on it's an energy level 1 and its orbital s. You can see that written here as well. It can hold a maximum number of 2 electrons because there's only one orbital there, and it's an s orbital, and those we know can hold 2 electrons. Energy level 2 has a little bit more energy, so we can fit a little bit more electrons in there, and it can have an s and a p. So we would call those 2s and 2p because they're in energy level 2. So now we know that s orbitals can hold 2 electrons and p orbitals can hold 6 electrons, so that gives us a total of 8 in energy level 2. So up till this point we've had 2 plus 8, we've got 10 electrons that this possible element can have. In energy level 3, we can now hold an s, a p, and a d orbital, so we call those 3s, 3p, and 3d. And you can see those written here as well. Now, remember our d orbital can hold 10 electrons, so if we add all those up, in total, energy level 3 can hold 18 electrons. And it is with level 4, 4f here, that we finally get that fourth orbital type. And when we add all those electrons together, we get 32 electrons. So as I said, this allowed us to really start expanding our understanding of how atoms can bond with other atoms and how electrons behave and how we get the different properties of different atoms. It also led to a greater understanding of the periodic table. If we could truly understand the properties of different atoms and why they exist, we can organize the periodic table in a way based on how these atoms react, how they want to relate to other atoms on the periodic table, other elements. So as I had mentioned before, our group 1, our alkali metals, they like to lose an electron, and our halogens like to gain an electron based on how full or how empty their orbitals are, their energy levels are. So we can see that they're all lined up in the same groups because they have the same properties. And that gives us a clue into who might react with who on the periodic table. You often see the alkali metals reacting with the halogens because one is losing the exact amount of electrons that the other wants to take away. So this is really where all this understanding of electrons helps us out. If you look at this picture here on the bottom left, you can see that hydrogen has 1 electron, this guy right here, in its first energy level. Oxygen, has 2 in its first energy level, which is good. That's full. Remember, we can only hold 1 s, and that's 2 electrons. In our next one, energy level 2, we can have 2s and 2p. 2s can hold 2 electrons, 2p can hold 6, so we want a total of 8 electrons in energy level 2. Well, oxygen has 1, 2, 3, 4, 5, 6. So it has the capability of holding on to 2 more electrons, and that's exactly what it does here. it holds on to two more of those electrons from those hydrogen atoms, and that's how we bond to form water. So we'll talk about this a lot more in the future, but this is just a peek into what we're going to be doing. And that is all that I have for you guys today. Talk to you later.